probably spend all day talking about each of these different circles here, but this is a glimpse into what rigorous, and we're getting ready to talk about reliable means that we've interpreted and had meetings with the agency, with the regulator to flesh this out and have conversations about what they mean. And so for a long time it was, okay, what does reliable and what does robust mean? I think a really important point here as where that came from was this difference between basic social and behavioral science research, we're talking like Module 6, switching studies, human factor studies, and TPPI, versus applied social and behavioral science research. So I was in academia for a little bit, and so are some of the scientists on the team. Research that T-Course does, that academia does, is so different than what industry and private companies do. So when we think about lab research, and then we think about, okay, true applied research really focuses on in the real world companies, but industry is somewhere in the middle because the regulator is asking you for the standards that the basic social and behavioral sciences are conducting in T-Core and academia, tobacco control. But then they're also asking you to be able to generalize to your population. So there's, we have internal validity and external validity, super geeky words. And industry almost has this, I don't want to say impossible, but a really difficult job in this space because they have to have both internal validity to say your methods are rigorous and reliable, but you also have to be able to generalize, right? And say that smokers will switch to this product. So it's a tricky place to be. Ultimately, looking here at what does it mean from a technical standpoint. So the FDA has made it very clear. Yes, they did call out randomized controlled trials and longitudinal cohort studies, absolutely. But when you really dig deep into it, as we have, it really comes down to they want to see a reliable and robust study conducted. What does reliable mean? So first, we use survey measures, right? So we have various constructs, we have various variables that we need to measure related to public health. They want to make sure, rightfully so, that the questions you're asking and the surveys that you're asking, that you can repeat them over and over again. You have reliable measures that will translate over and over and over again, so that it's not just a one-time single phenomenon, random occurrence, And in fact, so my colleagues and myself have started there with behavioral intentions. So with the TPPI, identifying psychometric analyses that support those TPPI switching studies so that we know when we're measuring behavioral intentions, risk perceptions, that we truly are measuring those variables. This is a direct correlation with, like I just mentioned, error. So you can't have results that generalize to the population that then gives you population health, right? If you have a study with questions and measures that have so much measurement error in them, and I know that some people are just like, oh my gosh, this is so much fun. So it is essential in any measure you're employing in your study that you have those reliable measures, and the FDA knows what you measured is what you intended to. It's a pretty basic point. Robust. Okay, so this is when you have a survey design that generalizes to the broader population. This is then at the foundation, this is inferential statistics. Descriptive statistics, descriptive results do not allow you to infer or generalize to your population. When you start dealing with power, p-values, less than 0.05, confidence intervals, various statistical aspects, that's what they want to see to say robustness means you can take your survey results and apply them outward. And so where do you get this? You get it from experimental research. So when they said randomized experimental or randomized control trial, what they're meaning is they don't want descriptive research, they don't want correlational research, they want an experimental design that allows for controlling potential variables outside the variable that you're measuring in hand, which, for example, might be flavors versus non-flavors. Okay, so that's a lot of that science background.